Welcome to Ask and Learn.
Hello friends, here it is given a 200 millimeter radius disc. So radius of the disc is given 200 millimeter. Rolls without sliding. So rolls without sliding. Knowing the distance VG is 160 millimeter, and at that distance shown in the disc has angular velocity 8 radian per second in counterclockwise direction, and angular acceleration 2 radian per second square in clockwise direction. We have to calculate acceleration of A. We can write this 8 k cap. This can be written as minus 2 k cap here. We are writing the direction vector. This is I cap, this is j cap, and this is k cap. Now, geometrical analysis. We start solving it. See the figure. We are assuming this point to be P. So let P be the point where the disk contacts the flat surface. Radius vector of G with respect to A is point 2 j cap meter. That of V with respect to A minus 0.16 I cap, this value meter. So our AV can be written as so position vector RAV can be written as j cap. Now velocity analysis. Angular velocity of g is given 8 radian per second. Velocity of p is 0 because pure rolling motion is there. So point of p contact to the surface would be at rest. Velocity of a will be a I cap क्योंकि it can slip along the plane surface. So velocity of v can be written as velocity of p cross velocity of p is 0. Omega is 8 k cap and this position vector already we have written 0.16 I cap plus 0.2 j cap. So on solving it, this velocity will be minus 1.6 I cap minus 1.28 j cap meter per second. Now the velocity of A, you may write velocity of V plus so velocity of V omega AV cross or AV vector. This is given VA I cap maybe we have calculated minus 1.6 I cap minus 1.2 J cap J cap cross minus root of 0.6 I cap minus 0.2 J cap. So on solving it, this could be written as minus 1.6 I cap minus 1.28. I have to make a correction here. 1.28 J cap. Just a moment. I should write more properly so there would not be any confusion. Minus 0.7746 omega AV J cap plus zero point 0.2 omega AV I cap. resolving into components along J cap, components along J cap, you may write 0.7746 omega AV to be equal to minus 1.28. So angular velocity you will get minus 1.6525 radian per second. Now acceleration analysis. Acceleration of A is J cap. Acceleration of G minus 2. Radian per second square K cap. Acceleration of P is omega square G into R J cap. It would be equal to 8 ka square into 0.2 J cap. So it would be 12.8 meter per second square J cap. Now acceleration of B point, acceleration of B point, acceleration of B with respect to P. So it will be acceleration of P plus acceleration of G cross R BP. Now substitute the value. So acceleration of V you will get AP having the acceleration 12.8 meter per second square J cap. Acceleration of G, angular acceleration of G is minus 2 K cap cross BP is minus 0.16 I cap plus 0.2 J cap. Here I am missing one term, AG. Just a moment. I am missing one term, omega square G RBP. Omega square 8 on solving. acceleration of v, you will get 10.64 I cap 0.32 j cap meter per second square. Acceleration of A, acceleration of V, acceleration of A with respect to B plus alpha AV K cross position vector AV omega square AV R vector AV. Substitute the value. Alpha AV K cap cross 0.6 I cap so on solving it, now we can find the value of alpha AV, resolving it into its component. A component so 0 is equal to 0.86615 minus 0.7746. So alpha AV you will get 1.1182 radian per second square, and if you equate the x component, you will get 12.755.2 alpha AV, and alpha AV we have calculated. So this answer will be 12.98 meter per second square. So answer of acceleration A will be 12.98 meter per second square along. That's all for this problem. Thanks.